Alright guys, let's have a look at questions 3 and 4 from the 2023 HSC Maths Advanced Paper. Question 3 says, what is the domain of f of x equals to 1 over root 1 minus x? A really great starting point for a question like this is looking at the question and seeing if there's any weak point that may have restrictions. And a great weak point is the denominator of this fraction here, because first of all, it's got a root, and we know that anything under the square root can't be anything less than 0. So it's got to be greater than or equals to 0. But the second problem is that because it's a denominator, it can't equal to 0 to begin with, and if we square both sides, then 1 minus x can't equal to 0 either. And so how do we merge these two conditions? We simply say that 1 minus x, therefore, can't equal to 0. That's fine, but it can be greater than 0. And so that is going to be your main condition from the merging of these two conditions here. And so don't freak out if we don't see that immediate answer option there. Let's simplify what we've got and then refer back to our answer options. So let's move this minus x to the other side. And we get 1 is greater than x. If 1 is greater than x, therefore that means that x is less than 1. And so, automatically, that means A is the best answer for question 3. Let's have a look at question 4 now. Question 4 says the graph of a polynomial is shown. Which row of the table is correct for this polynomial? So, automatically from the shape of this curve, I can see that this is a cubic curve. We can also see that there is a single root at that point and a double root at this point. So let's go ahead and tag that. So single root, and you've got double root there. Let's get rid of this so there's no overlapping with this question. Okay, so the single root tells me that that x-intercept has come from a bracket that does not have a power. In other words, the power of the bracket is 1. When you see that the power of a bracket is 1, you're going to end up with a single root. In other words, a single x-intercept. And a single x-intercept or a single root simply cuts through the x-axis at that point and continues on. But a double root is different, because a double root exhibits its bounce sort of behavior. So a double root is obvious when you see a part of the curve touching the x-axis at a certain point. Still an x-intercept, but it simply bounces off and continues on. And we can recognize that an equation has a double root when you have a bracket with a square. So that means that we can automatically rule out C and D, because none of those answers have a bracket that has a square. And so it is not possible to get a double root from C nor D. Studying my answer options for A and B, we see that the equation is actually the same, but the potential values of B and C, which are the two roots or x-intercepts, are very different. So let's talk more about that. If the value of B is positive, then let B equal to 1, because that is the smallest positive answer that fits under this condition. And if C is less than 0, then let c equal to minus 1. And let's plug them into this equation and see if we end up getting roots that have these sorts of values. Because this single root is on the left-hand side, it has to be negative. And this double root is on the right-hand side, meaning that the x value of that intercept is positive. So let's plug in these hypothetical values into the equation and see what we get. So here's our equation. And we know that in order to find your x-intercept, you have to let y equals to 0. Great. Now let's plug in our hypothetical values for b and c. Now, be very careful when you're plugging in something like this, because you've got the minus next to the c, but the c itself is a negative number, so you've got to be very careful. Always use your brackets. So that simplifies down to this. Now we actually come to the solving bit. So let's come up here where we get this bracket equal to 0 and this bracket to equal to 0. Let us go ahead and solve. Dividing both sides by -1 in order to get rid of that minus will give us x minus 1 equals to 0, and therefore x equals to 1. Square rooting both sides will give us x plus 1 equals to 0, and so x equals to minus 1. So let's try to make sense of what's going on here. So this is saying that if we were to plug in those hypothetical values, that the single root is occurring at x equals to 1, which is not the case. The positive root is a double root. This part is saying that our double root occurs at x equals to minus 1. It's quite the opposite in this case. We've got the negative root being the single root and the positive root being the double root. So that rules out option A, automatically making B the correct answer. Let's go ahead and check it. Just to go ahead and show you guys that it would work out in this case. So let's have a look at our hypothetical conditions over here. It says that b needs to be negative. So in that case, let b equal to minus 1. And since c is positive, then let c be positive 1. So the only thing that's going to change from all of this working out is these steps here. So let's go ahead and plug in those numbers. Again, be very careful with b because b is negative. Use your brackets accordingly. And c is positive in this case. We're just going to plug it in. Okay, so let's go ahead and simplify that. Okay, so now let's bring this up over here. We say that therefore this needs to equal to 0 and this needs to equal to 0. So dividing both sides by minus 1 in this case to get rid of the minus, we get x plus 1 equals to 0. And that therefore the single root is occurring at minus 1. That works with our graph over here because the single root is on the left hand side of the x-axis. It can be -1. It can be anything further than that. That's still correct. Let's have a look at our next condition here. X minus 1 all squared equals to 0. To get rid of the square, we square root both sides. The square root of 0 is simply 0. And so this tells us that there is a double root occurring at x equal to 1. That is still technically correct. This can easily be 1. It can be anything more than 1. But it does satisfy the equation and the conditions. And so that's why B is the correct answer for this question.